that clarifies it for the people that are not familiar with Chef yet. When we started with Chef here at LeaseWeb, our initial setup was based on a standalone VMware as EXXI box and a couple of Ubuntu VMs for testing. And we used snapshotting to refer to clean installations. And we had a development workstation with Chef and Knife and other tools we used for development. And we used Chef solo runs for testing, so there was no server involved yet. And later we added the Chef server to the mix to be able to use advanced Chef features like searching.
This was back in 2012.
Yes. In this environment we developed LSW base, which currently still forms the base for all of our systems. This cookbook installs standard tools we use every day for debugging or troubleshooting, like htop, vim, DNS utils, and load. And it allows us to configure system settings and allows us to, for example, enable and disable IPv6, configures the default editor, and allows us to configure system CTL variables.
It also registers the node location. It derives that from the host name, for example, and makes it searchable within Chef. So we can search for the closest name server, for example.
On this topic, a cookbook that's not mentioned here is our Unbound Cookbook, which we developed ourselves, which we use for installing our DNS resolvers in all of our POPs. And the Resolver Cookbook, which is mentioned here, uses this cookbook to search for all the nearest DNS resolvers and configures those for the systems. And we also developed LSW NTP, which configures and installs a fully configured NTP server. The limitations of this platform were that the provisioning was not really easy. It required manually creating new VMs and installing those using Ubuntu install CDs. And there were not enough resources on this platform to go on with our next project, which was creating the web hosting platform for the USA. And we required 10 concurrent VMs to run to be able to test this platform properly. At this point, we switched to a new KVM environment, which was based on KVM and libvirt. And we put plenty of memory in this machine to be able to accommodate all of these VMs for web hosting USA. The VM provisioning was done using VM Builder, and we used VM Builder to roll in a Chef client in the VM images. So if we fired up a new VM, it would automatically register with our development Chef server, and we could go on with configuring the VM. The cookbooks we developed using this environment were the already mentioned web and mail hosting platform for the USA, which involves nodes using Apache and PHP, HA proxy, MySQL database nodes, Plesk nodes, and Postfix and Dovecot nodes for the mail platform. Our virtualization team developed LSW CloudStack on this platform, which allows us to install CloudStack hypervisors and management nodes.
And together with our development team, we developed the lib app management cookbook. It's basically a library which provides a base for all our internal applications.
The limitations of this platform were that the provisioning was still relatively slow. VM Builder downloads, every time we created a VM, it downloaded the full Ubuntu installation, all the packages required, and the Chef client, etc., etc. So creating a new VM took about 5 minutes.
And it was pretty error prone due to the way it stores them on disk, leaves files behind, and lots of people make mistakes in rolling out new VMs.
Yeah, and disk permissions, etc. So at this point we switched to our own LeaseWeb Cloud platform, our CloudStack resource pool product, which is called LeaseWeb Cloud. Quick provisioning was done using Vagrant and VM templates, so a new VM could be fired up within a minute. And it also allowed us to chew our own dog food, as they say. So we use our own products and we can find problems and improvements.
And we did.
Yeah, and we did, yes. Where we are now, we have 236 servers currently under Chef control, of which 87 are from the hosting and infra team, and 149 for our LeaseWeb Cloud product all around the globe in Germany, USA, and the Netherlands currently. 150 cookbooks are in production, of which 50 we created ourselves and 65 are created by the community or vendors. And we rolled out major projects using Chef, for instance, the already mentioned web hosting, all of our cloud nodes, our public mirrors, and all of our DNS resolvers, our new LeaseWeb.com infrastructure, and most of our internal applications.
So we're currently doing a lot of deployments for our internal applications with Chef. Well, the current way we do this, we have our lib app management based cookbook. We have application cookbooks defining their dependencies, for example, which PHP modules do you need, which versions, which extra dependencies. They all define it as cookbook dependencies. This cookbook is highly dependent on the lib app management cookbook. As I told before, this is something we did with development, so it fits their needs. And we have an application management team, which then comes in, deploys, and debugs the application on production. I do have a small demo about, or a small introduction about our cookbooks and how we use them, but this is going to be interesting to do this with one hand. We trained with two, so it's going to be a little bit slower. We have the lib application management cookbook. Muchas gracias. The lib app management cookbook will deploy an administration user. I hope it's readable by everyone on the screen. It will make the administration user. It will give that user the sudo privileges to restart, for example, a web server or a database server. This is done during deployments. The user also has rights to manage the application, so it can access the document root, its storage directories, everything. .my.cnf files created for easy access to the MySQL CLI. So no passwords need to be remembered in that way. And the administration user can execute commands as www-data, so as the same user as our web application, so it can do clear cache and these kinds of operations. The cookbook also includes a default Apache vhost to make sure that most of our vhosts look the same and have the same way of operating. A way to implement this in Chef is to define a template. We ship this template, we call it an Apache vhost. It's in an Ruby type of file, template file. We define the cookbook in which it lives, so the app management cookbook instead of the cookbook we actually deploy. It notifies a restart on Apache, because if we deploy a new template, Apache needs to be restarted or reloaded in this case. And we need some variables there, for example, in this case, only a document root. Cookbook also requires something. We use Ubuntu 12.04. We don't use 14.04 yet, because most of the cookbooks still have some issues there. It depends on OpenSSL for the password generation. Maybe a database, depends completely on the application. Sudo and SSH keys to deploy it. As every cookbook, it has some attributes. Most of them can be default. There are stuff like the administration username, the group name, we call them app management. But maybe if the department changes name someday, we want to change this. If you need extra sudo commands, maybe to run a special command on that server. The application directory, a recording session. This is really handy for if you have multiple people working on the machine. Recording each of their sessions knows exactly what's happened and what the user did before. And a data there for non-volatile data. Into the usage, it's basically only included in your application cookbook, and that's where the rest of the configuration is done. Most applications also use a MySQL database, so we made a small resource around this, where you supply your connection information, probably localhost, but could also be a different server, the username and its password, and you call the function to create a database there. This in turn will create the database with a live prefix. It will give the user the rights to create backup databases or even extra users if needed by the application. And in turn, the README of the, for example, of an application cookbook is really small, basically contains nothing. So it makes more sense to actually show this cookbook. If it's still readable, this is our, this is basically the whole cookbook for our employee management panel. Some of the latest projects that development is working on, the infra team in this case. We include the log rotation recipe. We need Apache with mod rewrite. We need Apache itself. This is a wrapper we wrote around Apache to do some small modifications and tune it to, well, how we used it in most cases. We need PHP, mod airpath. This is related to our reverse proxy setup. This is the application cookbook, the app management cookbook we talked about. We also have one for Symfony, but it doesn't do a lot more than include some Symfony binaries. This is the part where the Apache configuration is deployed. We enable the site in Apache, and we enable a log rotation. That's everything that's needed to actually deploy a fully working employee management panel. At least the dependencies for the management panel, because this is the point where currently application management comes in and deploys the application into production.
Yeah. So as you heard, there are a couple of manual steps involved in our current process, which brings us to the risks of the current setup. Currently there are no safeguards in place, so basically all actions that are done on our production environment can have large consequences. As you have heard, we have 200 servers in production now. So if someone screws up there, it could have consequences for over 200 servers. The applications are still manually deployed by application management. Our cookbook version management is currently a manual process. So if we want to bump, for example, the Apache cookbook, we need to be really careful and check the change logs of the cookbook, because we use the community cookbook. So we need to first check very carefully all the changes before we push it to production, because, well, yeah, we have about 30 servers using this cookbook, I think, or more.
More.
Yeah. And there is no automated testing done for our own in-house developed cookbooks yet. So if anything goes wrong in one of the cookbooks we use in production, things can break.
Basically, we're living on the edge.
Yeah. Which brings us to where we would like to go. We had to throw in a meme here. So.
Automate all the things. Almost everything.
So where we would like to go is automated testing using Test Kitchen, which is going to automatically test our cookbooks. Better cookbook release management using Jenkins, meaning version control, automated testing, syntax checking, and no more manual cookbook uploads. So we will basically use Git instead of Knife to manage cookbooks. We mark a cookbook for release in Git. Jenkins will automatically test it, and if there are no problems, it will be published to production. And we would like to do automated app deployments.
Not taking away the jobs of application management,
no.
But we want to automate at least the deployments. We still have troubleshooting, testing, and integration there. I see somebody not being really happy about it.
No, he actually asked for it last week. And this all results in a continuous delivery and deployment pipeline. Now, we have a demo for you of deployment of a fully automated deployment of one of our public mirrors using Vagrant, LeaseWeb Cloud, and Chef.
Because we can do it. So.
It actually works.
Yeah. This is basically everything that's needed for the LSW mirror. It's the complete cookbook. It includes a changelog, Burks file. Burks shelf is used to define dependencies and pull them in automatically. We have, of course, a README, changelog, the Vagrant file, because we use, as said by Hans, we use a Vagrant system to spin up VMs. We have the metadata and its normal stuff. Extra things you might see in here is the Chef directory. This is where we hold a data bag dummy for the SSH keys. So let me quickly show you the Vagrant file. The Vagrant file is something you might already know because you used it with VirtualBox or any other type of Vagrant compatible virtualization system. We define the VM. We define that we need Omnibus to install Chef. We need Burks shelf to do the dependency handling. We define the actual VM and its name. In this case, it's our LSW mirror. We have a small part that's related to CloudStack. In this case, because we need it a bit quicker, we have a service offering called Nico Turbo. This is one of the biggest offerings we have in the system. because he needed to test really big things. Normally we run VMs with only 1 or 2 CPUs and 1 gig of RAM. This is more than enough. As said, we have those data bags for our SSH keys. And we need some metadata in Chef to get our cookbook running. In this case, it's a mirror, so we want some speed test sizes. We have some mirrors, for example, a demo repository, and I think there's even a real one down here. Yes, the Gentoo portage. So it will actually try to sync this only every 15 minutes, and we might get lucky. Now for the actual work, we only do a vagrant up, and this should, it's demo time, so should do everything. Give it a couple of seconds to connect actually to our CloudStack environment. It will now try to bring up a new machine. It also does its Bergshelf magic, so it pulls in all the dependencies. As you can see now, it requested a new machine. It will bring it up in an internal network, so none of our testing is done on external IPs, keeping it safe that if we do something wrong, expose some sensitive information, it's only accessible by VPN. So my laptop also has that VPN connection. There's our Nico Turbo template again. We use Ubuntu 12.04. And it should become available now because it's trying to SSH. The next steps are actually done from my laptop, so it's now trying to connect over SSH to the machine from my laptop. And as long as Wi-Fi and the tunnel holds up, we should see it become available. Yep, yeah, there it goes. So it will now copy over the cookbooks from our Bergshelf directory. It will download Chef. So actually the Chef client, this is just a wrapper around a Debian package. It will install Chef. So this is just normal DPKG output. The first Chef solo run is done to initiate Chef. And from here on, it's our cookbook running.
It will first start with the LSW base, and then it will install packages like Nginx, VSFTP, and rsync that are required for our mirror.
It should not take more than a couple of minutes.
Oh man!
Really, really, we tested this how many times? Demo time, and now it explodes. Well, we can give it another provision.
That's weird. We have a strange CloudStack node or something.
Didn't they run CloudStack updates like yesterday? CQ today? I hear my little colleague going on there because it fails on our virtualization checking.
Yeah.
That's why we need the tests, right?
This is
exactly.
This is kind of parts why we need the tests. Yeah. Let me pull up the actual CloudStack environment as well. Let's see what's going on.
You can try and destroy it and create it again. Maybe get a new CloudStack node.
Of course, security first, session expired. Then insecurity because I store my passwords in my browser.
This is demo, right?
This is demo. So, well, we see the mirror. It is running. It is spun up.
No,
but it craps out on the virtualization detection. So I can do one more destroy and try to respawn it, but I think something has changed during the updates. So actually instances, creating them, destroying them can all be done through Vagrant. It's a really nice plugin called Vagrant Cloud Stack. I'm not letting updates win from our presentation. Because I think it's in here. So you're gonna live. If it still doesn't work, you're gonna live without test files. We shall get this thing working.
We have about 5 more minutes.
Oh, the whole deployment of the system normally in all our demos, it took 3.5 to 4.5 minutes. It would fully deploy a machine, including test files and a repositories, everything.
I think we have a little waiting music.
But,
Yeah.
why do we not, you said that there was a problem of doing version control. I thought that you were also using Git or whatever.
Yeah, we are using Git, but I mean cookbook version control. The chef server stores certain versions of cookbooks, and updating those is currently a manual process. And because we also use around 65 vendor cookbooks, and they keep changing. The community keeps working on them. If we want to use one of the latest versions of those cookbooks, we really have to check what has changed before we push it to production, because the interaction with other cookbooks could cause chef runs to fail or configurations to change in a way that we do not want. Still not working?
It's still starting in the background, so we should get our... It's stupid. I know the commands by heart until you have a demo, and then you lose everything in your mind, including the how do block commands. Well, it's going further now.
Yeah, it's working.
So it spawned on another, probably on another node.
Yeah, I think we had a weird node.
Still, we can check. This one is the old one. You see it's automatically destroyed. No, you can't see the node, unfortunately. This one is the new one. It's actually running. So... Still going strong.
Yep, it's installing VSFTPD now.
Yep.
And it also ran apt-get update to get the latest Debian repository headers. And here we go.
It could still fail.
Default editor configured. Yeah, it's going.
Chef also determines its way of processing the resources automatically. So it's not said that everything that's in one order in the cookbook will actually run in the same order in production or in when you deploy it. It's done automatically.
It's done.
It's done. So
in 3 minutes and 50 seconds.
Demo saved. The IP addresses are configured automatically, so I now request the SSH configuration, which includes the IP address, so we can finish off this demo. If CloudStack works along. Oh, come on. Ruby output, it has a lot of it. There we go.
I feel
we have
a bit
an IP
like
address.
Bill Gates now during the Windows presentation.
Ta-da!
Yes.
And here we are.
A fully working LeaseWeb mirror with even speed test files, so I could download them. Yeah, there they are. They actually work. They do appear to be 4 megabytes smaller, but hey.
So that's it for our demo. We have some time for questions.
Yes,
Or
questions,
do we?
anyone?
I don't know. Oh, 2 minutes. Questions? Yeah, Antonio?
You have to answer them. No mic anymore.
Well, just one quick question. Using Chef to deploy well with the applications, which is well a goal that we want.
Yeah.
My only concern is I saw that it runs every half an hour.
Yeah, it does.
How do you guys handle if something goes wrong during one of those deployments? Since there's no testing ongoing.
Yeah, well, yeah, that's kind of a requirement before we go to automated deployment, but yeah.
But for example, nowadays, if you change a cookbook and you deploy and you commit it to Git, you deploy it to the production machines, and something goes wrong, it happens.
Yeah.
Probably. How do you guys solve that? Imagine that the Apache cookbook, it's something wrong with it because there was a typo that you didn't notice.
Yeah.
How do you avoid it from getting deployed on all the servers, and how do you avoid it for the next half an hour to be redeployed?
Well, in the future, we have automated testing. Currently, it's just having monitoring handling quick enough. It's how, for example, I think Etsy does it that way. They have strict monitoring and everything. They have lots of servers as well. So as soon as they see cookbooks failing on their servers, they roll back.
And we
So
could
it's
do the same for
basically
applications.
Type quicker than the cookbook rolls out.
Another question over there? Yeah?
So who's actually creating the cookbooks currently? Is this independent of departments? Can it be that 2 departments are working on the same cookbook and trying to push them to the chef server?
No, the only ones that can push to the chef server is hosting operations, but the changes can be done by a development department as well, and mostly they are done through pull requests, so we can also review them and apply them.
Okay, so you're using something like Garrett for possibly testing and peer review as well, before they get pushed to the chef server?
Yeah, we have peer review using Stash pull requests and 2 reviewers. And testing is done manually currently.
Okay.
Before
Thanks.
we deploy to production.
No,
Okay.
well, thank you, Hans and Marcus.
All right.
And of course, René as well for holding the microphone.